In 2025, the Earth will face a threat from space that could cause trillions of dollars in damage, throwing the world into chaos. And this is not a news headline on a well-known TV channel. This is a reality confirmed by NASA and other space agencies. Why haven't you heard about this yet? Yes, because real problems are not as popular as the Mayan calendars or Vanga's prophecies, but seriously, scientists know about the approaching catastrophe and are preparing for it. Yes, and you probably heard something out of the corner of your ear. Remember when Elon Musk suddenly lost 40 Starlink satellites in February? We heard about the problems of the Swarm satellite network, which suddenly began to fall to the ground. Have you read about the Carrington event, where in 1859 telegraphs around the world went dark and the planet plunged into chaos for several days? All these are interconnected events that are a prelude to disaster 2025. And we'll start understanding them with Elon Musk. On February 3, 2022, the Falcon 9 rocket routinely launched another 49 satellites of the Starlink global internet network into an intermediate orbit. They parked somewhere 350 kilometers above the ground, and everything was going great. But on February 8, SpaceX announced that 40 of 49 satellites were lost. It's a serious blow to the corporation's wallet, because the 67 millionth launch, the rockets went to waste, and that's not counting the price of the satellites themselves. But why did this happen? The Sun is to blame, which on February 4, a day after the launch, decided to make a fuss. A huge amount of substance was thrown towards the ground. This solar wind, having reached the Earth, interacted with its magnetic field, causing what we call a geomagnetic storm. The Starlink satellites destroyed the indirect effect of this event. Modern satellites have some means of protection against the direct effects of magnetic storms. The Starlinks themselves turn on the safe mode function, which protects them from electromagnetic disturbances. However, satellites that have not yet gained altitude cannot escape the drift. 40 satellites were destroyed by some kind of explosion or anomaly that burned their electronics. They simply sank in the Earth's atmosphere after falling on it. Why is that? Because space is actually not empty, and even more so around the Earth. Even at an altitude of hundreds of kilometers there is no smell of vacuum. Small amounts of oxygen are present even 300 kilometers above the Earth. And the interplanetary medium starts from as many as 3,000. Let us leave aside the fact that even there is no complete vacuum. What is important to us now is the problem of the Starlink satellites, which is identical to the problems of all devices in low Earth orbit, including the ISS. Imagine that you are walking into the wind. The weaker it is, the easier it is to go, the stronger it is, the more difficult it is. This is roughly what satellites and space stations encounter. On their way they overcome the resistance of the environment. And the solar wind, consisting of particles moving at high speed, increases this resistance. The environment around the satellites becomes denser, and therefore it becomes more and more difficult for them to continue spinning in orbit. And as a result, the satellites slow down and begin to sink, falling deeper and deeper into the Earth's atmosphere, where, in turn, the environment is even denser. And there is a risk of an uncontrolled fall. In calm times, all near-Earth vehicles use correction engines to eliminate problems. The International Space Station can lose 100 meters of altitude per day, and its orbit is adjusted about once a month. The Starlinks are also correcting, but those launched on February 3 did not have time to enter a stable orbit to start this process. At first glance, it may seem that they were simply unlucky in this regard. A random flare in the Sun is not predictable, and everything can be attributed to force majeure, but this is not so. This is where the European Space Agency's network of worm satellites comes into play. It was launched in 2013 to study the Earth's magnetic field. The guys fly just above the International Space Station, in orbits from 460 to 530 kilometers. For the first 6 years everything went fine. the satellites exceeded the warranty period and continued to work, falling towards the Earth at a speed of only 2.5 kilometers per year. Something strange has begun. Since December 2021, the rate of decline has increased 10 times. By April of this year it had reached 20 kilometers per year. The trend, as you understand, is not the best, but what is most important, unlike the 40 Starlink satellites, is in no way connected with single flares. Everything indicates that the space around the Earth is becoming denser, and it is becoming more and more difficult for the apparatus to move in it. And not by just a fraction of a percent, but several times at once. Who is to blame? The sun and its wind, only now we are not talking about single flares, but about their steadily increasing number, which saturates the Earth's orbit with more and more particles. And here lies the real irony. It lies in the fact that there is no secret in the ongoing processes. Our sun has simply begun a new cycle of activity, which will reach its peak in 2025. Moreover, it has been known for quite a long time. Scientists began measuring the solar cycle in 1843. And now we clearly know about the existence of 11-year, 22-year, secular, 500-year and other global cycles. Within the framework of the topic, we are interested in the 11-year-old, because current problems not only in space, but also on Earth are connected with him. The root of the situation lies in the electromagnetic activity of the Sun. On average, every 11 years, the north and south magnetic poles of our star change places. This is accompanied by strong magnetic changes. They interact with each other, twist, turn over, collide and do whatnot. And where magnetic fields are disturbed, sunspots appear. They are the areas of greatest solar activity. Without delving into complex terms, let's immediately move on to the consequences. The visible results of this magnetic chaos and sunspots are the very flares that send colossal amounts of matter into space at sublight speeds. A familiar example of the collision of such particles with the Earth's magnetic field is the northern lights. We talked about a less familiar form of atmospheric densification, which causes drifts of satellites, a little earlier. Now let's talk about the third example of a terrible geomagnetic storm in 1859. It is also called the Carrington event, named after astronomer Richard Carrington, who observed the flares live. Usually on Earth we see the consequences of solar emissions after a couple of days, because we are not talking about light that lasts 8 minutes. We are talking about heavier particles, but even a couple of days traveling from the Sun to the Earth is very fast. But Carrington saw something even worse. The consequences of the flare, which in the form of a coronal mass ejection, reached the ground in just 18 hours. This speed is due to the fact that past flares cleared the way, and the solar superstorm covered the Earth much faster. Telegraphs across Europe and North America failed. This was accompanied by curious events when even a device not connected to electricity sent messages. Either he gave an electric shock or shot sparks. Also, the northern lights are usually characteristic of polar latitudes. We saw it on the cube and almost on the equator. Gold prospectors in the southern United States even woke up, deciding that it was already morning and the couple had to go to work. Panic began in many cities, because people believed that a fire had started. In reality, of course, no magic happened. The Earth was simply covered with an insane amount of solar wind. Some delayed the magnetic field, creating auroras, while some interacting with them created a mess with equipment and people's heads. Yes, they also affect human health. And when your grandmother complains of a headache due to a magnetic storm, do not rush to laugh. According to scientists, 3 out of 4 people can actually feel their influence. Fortunately, this is not fatal, but there is one caveat. In 1859, even telegraphs were rare, and people traveled on horses. There was no talk of any internet satellites or television. And now I remember about sparkling telegraphs a century and a half ago, and let's transfer this to the modern world. The fall of Elon Musk's 40 satellites will seem like a child's toy. Our power grids, satellites, smart sock wearers will take such a hit that scientists don't even try to predict the consequences. They operate only with rough calculations, according to one of which the damage to the Earth's economy will amount to about $4.5 trillion. Why conditional? Because in this case, not everything is measured in money. On paper, GPS satellites cost several $100 million, but this does not mean that printing that amount will teleport failed satellites into orbit. Just like the power grid will have to be restored not with money, but with labor and materials, the production of which may also suffer. In general, everything can be so terrible that it's scary to even think about it. So let's think better about dry mathematics, returning to 11-year solar cycles. Looking at the graph of the last centuries, it is not difficult to come to the conclusion that they are developing, plus or minus, according to the same pattern. In the first years, the sun gains power, reaches its peak of activity, and then calms down. Right now we are in the 25th solar cycle. It started in 2019, and is just now reaching its peak. In 2021, the number of magnetic storms has tripled compared to calm times, and this is just the beginning. If a graph that followed the same pattern 24 times is repeated 25 times, then somewhere by 2025 the sun will reach its peak activity. Therefore, a storm of the level of 1859 should be expected. And here the most attentive ones ask a logical question. The 24th cycle has been going on and reaching its peak in our lives. So why didn't we see anything? The answer is not very optimistic. Actually we saw it, but you and I were simply lucky. On July 23, 2012, an unusually powerful coronal ejection of mass from the Sun occurred, the amplitude of which fully corresponded to the ejection of 1859. We were saved only by the rotation of the star, which went towards the apocalypse past the Earth. If the outbreak happened just 9 days later, it would be directed at our planet, so it's not worth saying that we didn't see any flashes beyond that, and all this is an invention of reptilians. Humanity is simply lucky with a measly 9 days difference. Which, by cosmic standards, is a trifle, but earlier events either occurred during smaller storms, or did not have a destructive effect similar to the modern one due to the backwardness of the technologies of those times. Now the stakes are much higher, and two things are very funny here. The first is that 2012 really could have been a mini end of the world. And the second is that the era of space expansion of mankind occurred during a period of calm of the sun. The dawn of private satellites, SpaceX, Mars rovers, and the space programs of India, China and other countries came in the middle of the last decade. Right at the end of the cycle of a relatively calm sun. If you dig deeper, Neil Armstrong's team miraculously missed the solar flare as it flew to the moon. In general, the next time you want to blame fate for bad luck, hold your horses, you and I are very lucky people. Yes, there is good news too. Single super powerful flares are only special cases of increased solar activity. Its stable effect is most associated with the compaction of matter in near-Earth orbits. And here humanity has received a free way to combat space debris. There are now a huge number of highly damaged satellites and debris in orbit. It will become more difficult for them to drift freely, and many will fall to Earth and burn up in the atmosphere. At the same time, it will be possible to spend more money on combating global warming and increasing solar activity. But if you still shouldn't seriously dramatize the effects for astronautics, there are no fools at NASA, SpaceX and other space agencies. And there has long been a saying among engineers that there is no such thing as bad weather, only bad preparation. So they are preparing the Artemis lunar mission with a new version of the Starlink satellites and other space programs, with an eye to increasing the amount of solar wind and flares. There are entire organizations that track weather in space. And if in 1859 it was almost impossible to respond to a solar ejection within 18 hours, then in 2022 this is enough to make the necessary adjustments to the operation of spacecraft. We are quite well prepared for the next change in sunny weather, but still the risk factor is very high. In July 2025, there are predicted to be 115 large sunspots, many of which could cause us a local apocalypse. And to remind you that humanity is just a tiny blue dot in the vast expanses of space. Our internal disputes, even on the scale of the solar system, look small and insignificant, but for the galaxies we are dust and, hopefully, a catastrophe on a global scale will not be useful for realizing the need for the whole Earth to work on problems. Perhaps we still have a chance to understand this peacefully. See you again, friends.